In today's video, we are going to learn transient response of a series RC circuit using MATLAB Simscape. Here we will cover first one, circuit design, second, the theory and the equations, third, we will see how to construct the MATLAB simulation setup, fourth, we will analyze the output waveform with explanation. So let's get started. First, let us understand the basic concept. A series RC circuit consists of a resistor, a capacitor, and then a voltage source. Okay, here we are using DC voltage source. When a step input is applied, the capacitor does not charge instantly. Instead, it follows an exponential behavior which is called transient response. This is about the short explanation of what is RC transient. Okay, let's see some theory behind it. Okay, let's look at the theory behind this, where by using Kirchhoff's law we can derive V is equal to VR plus VC, where V is the total voltage applied across RC element and VR is the voltage across the resistor, VC is the voltage across capacitor, which means V is equal to IR plus VC. Okay, IR is the drop across resistor. Since the current through capacitor is represented as I is equal to C into dVC divided by dt, okay, which is change in voltage with respect to time. And then by substituting this V, we will be getting RC into dVC divided by dt plus VC, which is the total applied voltage. We can also derive the instantaneous voltage Vc of t, which is equal to V into 1 minus e power minus t divided by RC, where time constant tau can be represented as RC for the series RC circuit. In our case, R is equal to 100 ohm and C is equal to 10 microfarad. From this we can calculate the tau, which is R into C, which is 0.001 seconds. Now this means at time, that is at one time constant, 63% will be charged. At 5 time constants, the capacitor will be fully charged. Let's build this in MATLAB Simscape. For that, you have to go to this MATLAB window. Here just click on this home button. Under the home button, click on this new. Okay, expand the new tab, where you have to click on Simulink model. After this, you have to create a model from blank model. Once it is created, it shows the name as untitled one. Now you have to save this file with proper justifiable name. You can choose any location and save the .slx file under the name as RC underscore transient. RC underscore transient, the name I have chosen. Now save. It is now saved as RC transient. Now you have to search for components by clicking on any empty site by using your mouse left button. Okay. Now I am searching the controlled voltage source from foundation library, which is similar like RL transient. We already uploaded the RL transient, you can take a look of it. Second, resistor, from foundation library. Accordingly, you have to place the component. So the third one, capacitor. Just rotate the component by using Ctrl plus R, and then voltage sensor you have to select. You have to keep the voltage sensor in parallel, and then the parallel across the capacitor, and then step input you have to choose step. So click on step. Here you have to keep it as it is, and then Simulink to PS converter. You have to place it here. I have to convert this step input. That is, the black color represents Simulink component, the all blue color represents Simscape components. Okay, the power system components. So we have to convert. We can connect it like this also, and then we need solver configuration. And then electrical reference, we need to use electrical reference. Now you can connect these components. Additionally, we need scope. For scope, here I am going to combine two signals by using mux. Now to have proper comparison, you can keep like this, you can connect it as it is. Then you can connect this voltage sensor across the considered elements. Here R and C are considered elements. Then you have to insert PS to Simulink converter. Now to connect this with scope. Similarly, you can connect this voltage sensor with this. Once again, PS to Simulink converter. Connect it like this. This is actually the exact circuit what we want. This is the DC source what we focus. DC source, and this is, here we are using two values. One is 100 ohm, so I am representing 100 ohm. So here the capacitor value is 10 microfarad. If you want to use, you can use symbol also, mu symbol. I am typing as microfarad. So you have to set the values. Here you need to set the step value as 0.01 seconds, and the initial value is 0, the final is 1. These settings you have to set before running the simulation, and apply OK. Also you have to set the value of resistor. Here it is 100. You have to select all the component, and you can make it as bold. And here you can represent this as R response. So you can represent here as C response. And here also you have to set the values 10 microfarad. 10 microfarad capacitor. For that, here I am representing 10 e power minus 6, 10 e minus 6. And now you have to specify some name. Transient response of series RC circuit. Here you have to mention the name. You can keep the name like this. You can center and you can make some colors. You can also keep it with some style like this. You can keep it. Okay. Here you can also add some images. Okay, here if I want to specify this values in the time constant values or anything, if I want to save, you can save any image. This device, you can save this as image. Or if I want to show the response also, I can show. Okay, let me show the response. This is actually the response of the circuit. Here I am copying this as, or I am converting this as image. Okay, converting this as image. For example, this is at last I will tell you. At last I will tell you the trick. Now we can run the simulation. This is a complete setup. Now you have to set the time as 0.15. Here this step signal is converted into physical signal using this Simulink to PS converter, and it is applied to the circuit, and everything is connected in series, that is resistor, capacitor and then DC source. And here we measure the voltage across the resistor as well as voltage across the capacitor. Okay, now you can save the file once again. Now we can run the simulation. Now it is, some simulation has been run. Now you can open this scope. Just double click on this scope and you can open the scope now to visualize the response. Here the scope is showing the response. Here you can have some settings. Click on scope button and settings. Just click on settings. Here you can click on the display where you can type it as RC response as a title. So legend, grid is off, and axis, here it is auto, and here you can check it as white color, and this is black color, and this one is like this. You can choose any light color oriented, that is for scope background you can select any light color. under line you have to choose. For R response you have to choose, okay, line I can choose. You can choose it as 4. You can keep it as, okay, you can keep it as black color. For C response you can choose it as any dotted line with 4. You can choose as pink color, okay. Like this it will show the response. And y-axis you want to label, you can label, okay. Y-axis you can label. Here we no need to label anything. Similarly x-axis also you can label. You can also mention the limits, but there's no need to worry about this. Everything is all set. You can close. This is the exact simulation response. This is the output what we are getting. Here the print color represents the capacitor voltage, which starts from 0 and increases exponentially and reaches final value of 1 volt. Okay, we can see the final value of 1 volt it is reaching. And the black color represent initially it is having high peak and then decreases rapidly, finally becomes 0. Why does this happen is, at the beginning the capacitor behaves like short circuit, so the current is maximum. At steady state the capacitor behaves like an open circuit, so the current becomes 0. Okay, this is a major thing. Here the concept is very important in filters. Okay, filter design we can apply this concept, as well as timing circuits we can apply, as well as it is highly useful in many power electronic applications. And nowadays the recent topics are the hot topics. We can use it in EV battery charging systems. Okay. Also let's summarize the concept as, here the RC circuit is a first order system. Okay, and the output is exponential, as well as the time constant controls the speed. That is a key point. And then the capacitor voltage increases gradually, as you can see, and the current decreases exponentially. Okay, here we are focusing on voltage. If you want to compare the voltage as well as current waveform, you can also add current sensor in series with the RC element, and you can compare the voltage as well as current response. Okay, I hope you understand the concept clearly. And once again, let me tell you how to add image in this simulation. Okay, first of all, let's save a simulation. I can save this as simulation. This is image. Okay, I can save this as image. In your device, Control plus yes. In downloads, I am saving. Okay, as a screenshot you can save any name you can give, and go to the simulation. Okay, this is the simulation what we have constructed. Here just click on this image. Here you can, it will show you some image button. Just click on this, drag it and place it like this. Okay, so you can type RC response. Here in this one you can just double click on this, and it will direct you to this your device location, and just click on the saved image and open. It will show you the response. Okay, it will show you the exact response here. You can also visualize the response directly by importing into your simulation. Okay, this is the one way of representing your experiment. Okay, like this you can represent. Also you can copy this. Okay, you can copy this and you can save it in Word. Okay, how we can copy this? We can copy this by using the snipping tool, or you can copy the complete file using go to format, here we have the screenshot. You can select any of this, or I can select the send to bitmap to clipboard. I have selected, and now you can go to any word file. You can open any word file, or you can just Ctrl plus V, you can paste it. It will show you the response. Okay. For experimental purpose or for lab experiment, you can use this technique to represent the circuit as well as response. Okay, as it is, you can make it. Okay, you can also fine tune it. Okay, you can have the exact response, the clear cut response. You can fine tune it. Okay, also some other tricks I want to share, that here we are using more wires. Okay, instead of using wires, we can use a block called go-to now to represent a wireless way of communication. Okay, just type as go-to. Here it will show you the block go-to. You can name this, you can name this go-to tag as R. Okay. Now here, if you are touching the right corner of the go-to block, it will show you some arrow. Okay, just click and drag. Just click and drag and place it anywhere in the empty space. And it will show you another one block. Okay, this block is a from block. This is from this go-to. Okay, the data is from this go-to. Okay, now you can connect this to this one. Similarly, you can also insert another go-to block here, and you can connect it with this C response, and you can name the tag as C, capital C. Okay, here once again you can just move your cursor near to this go-to block, and where the blue color arrow is showing, once it is showing, just click and drag. Okay, where you can get the from block. Okay, with the same tag. Okay, now the system is wireless. Okay, you can wirelessly represent your system. Okay, this is very compact. This is very useful when you are going for complicated simulation or complex simulation, or you can represent all signals in a sequence manner. Okay, in sequence manner as well as in neat manner. Okay, without any you can easily identify error, or you can easily debug the errors. Okay, with the help of these tricks. Okay, and if you want to found this type of videos, or it is very helpful, you can like, share and subscribe, and we will see in the next video. Thank you.